How does an aldehyde look like? And how does a ketone look like? Okay. Through that, for us to get an easy understanding of how an aldehyde and a ketone look like, we're going to draw the structure of two monosaccharides. Okay. We need to draw the structure of two monosaccharides. And from that, I believe it will be easier for you that is over there watching to know the difference between an aldehyde and a ketone. And now, we're going to draw the structure of a glucose and the structure of a fructose. Okay, the structure of the glucose and the structure of a fructose. Okay, so the first thing that you should know that for a glucose and fructose, they're having how many number of carbon atoms? Okay, because the number of carbon atoms present are always 6. Okay, so we're going to use the Fischer projection in drawing the structure. Okay, so when using the Fischer projection, we already know that the number of carbon present is 6. Okay, so we'll draw the carbon present. So 1, okay, 2, remember the Fischer projection, 3, 4, 5, and even 6. Okay, 6. And now for an aldehyde, remember a glucose is an aldehyde, it will have a double bond here to an oxygen, and over here we're having a hydrogen atom. Okay. And the second group is that the carbons are also bonded to each other. Okay. So the second group over here, we will be having the OH, hydroxyl group. Okay. Here we're having the hydrogen. Over here we'll be having the hydrogen, and on this side we'll be having the OH. Okay. Over here we'll be having the OH, and over here we're having the hydrogen. Over here you have the OH, over here you have the hydrogen, and over here we're having CH2OH. Okay. Now this one is the Fischer projection of a glucose. Okay. That is how the glucose look like. Okay. That is the Fischer projection for a glucose. And now for a fructose, you get that this is how it looks like. You have the carbons, first they are 6. Okay. So you have the 1, 2, 3, 4, 5, 6. Okay, 6 carbon atoms. Okay, and they are bonded together. They are bonded together. Okay, and we have that. The first one we are having CH2OH. Okay, then we have a double bond to oxygen atom. Okay, and over here we are having the H. Over here we have the OH. We have the OH. Then over here we have the OH, H, OH. You have the H, and you have the CH2H. Yeah. Now, this one is the Fischer projection for glucose. This one is the Fischer projection for fructose. Okay. And remember that the reason being as to why I drew them was for us to get an easy and faster understanding of how does an aldehyde group look like and how does a ketone group look like. Okay. So, when we check on this one, we have something over here. I'll check on that functional group. Okay? Let's see, you have one over here. Okay. I believe that when we check on this one, we have carbon. Okay? The first carbon is having a double bond to an oxygen atom. Okay? And also an hydrogen. Then the carbon is attached to another carbon. When we get on this other one, okay, we have that the carbon, the first one is an alcohol, okay? Then it is attached to a carbon, and now the second carbon is the one now attached to a double bond of oxygen. I believe you can see the variation. Okay, you can see the variation. Over here, you have the O is attached to the second carbon. Okay, but over here, we are having the oxygen atom attached to the first carbon. So that should enable you to differentiate between an aldehyde group and a ketone. Okay, for an aldehyde group, the first the oxygen atom is attached to the first carbon, running for an aldehyde group. But now for a ketone, you get that the oxygen atom is attached to the second carbon atom. Okay. Yeah, so this one will enable you to differentiate between an aldehyde and a ketone. So for an aldehyde, this is how it looks like. And for a ketone, this is how it looks like. Okay.